Hello, my name is Zachary Henke, and I am the Predator Biologist Crew Lead within the Predator Research and Ecosystem Management Division of the Institute for Wildlife Studies. Today, my talk is going to be on the impacts of wildfire on San Clemente Island's rodent populations. San Clemente Island is located off of the coast of Southern California, and it is the southernmost of the Channel Islands. Since 1934, San Clemente Island has been owned and operated by the United States Navy. San Clemente Island is mostly a volcanic island comprised of steep marine terraces. It has a diverse ecosystem comprised of three main habitat types. The first habitat type, composing only a small percent of the total, is canyon shrub and woodland. The second habitat, which used to consist of a majority of the island's habitat, is marine desert scrub. However, a large portion of this habitat has since been removed by invasive grazers, such as introduced goats who used to live on the island. And the habitat was replaced by grassland communities consisting of both annual and invasive grass species, which makes up the majority of the habitat now on San Clemente Island. Among the diverse ecosystem, there are many important wildlife communities. Among the most important wildlife community is the rodent community, which is composed of three main species: the house mouse, the deer mouse, and the black rat. For this talk specifically, we're going to be focusing on just the deer and the house mice. The mouse population on the island is a vital food resource for many wildlife species. Species of important concern include the loggerhead shrike, also including the San Clemente Island fox. They are a vital resource for predator species also, such as the American kestrel, the red-tailed hawk, the white-tailed kite, the sharp-shinned hawk, the red-shouldered hawk, and the Cooper's hawk, as well as the short-eared owl, the burrowing owl, and the barn owl. Since the mouse community on San Clemente Island is a vital resource for so many species, mouse population demographics are routinely monitored. Mouse densities have been traditionally calculated based on capture-recapture data obtained at our three historic trapping grids. Each grid represents a different nominal habitat type, with Wall Rock representing canyon shrub and woodland, Warsaw representing marine desert scrub, and Twin Dams representing our grassland communities. On July 25th of 2024, an anthropogenically induced wildfire occurred. The fire burned approximately 3,389 hectares, or 25% of the total land area. This fire was unique as it was the first time that any of our three historic trapping grids had been affected by wildfire since 2015, when capture-recapture data was first collected. Twin Dams was the trapping grid that was affected by the fire, and Twin Dams is our grassland community nominal habitat representative. Twin Dams appears at the northern end of the fire, indicated here by the green dot. Within the Twin Dams grid, these photos were taken. It is important to notate that the photo on the bottom left and upper right are depicting the same exact coyote bush, which gives us the ability to observe just how much of an impact the wildfire has. Most ground cover has been completely eradicated, and if you look in the image on the lower right, in certain parts of the grid, we have a complete loss of vegetation entirely. Our trapping methods include a 7x7 49 trap configuration, which can be observed in the photo on the lower right. We use HB Sherman traps with a bait consisting of a peanut butter oat mix with the addition of celery, which can be observed in the image on the lower left. Our traps are housed within a larger tomahawk trap in order to prevent other species such as foxes and birds from influencing the traps, which is seen on the image on the upper left. The grid is checked every morning for 5 consecutive days, resulting in a total of 245 trap nights per grid. The image on the lower right shows an example of our data sheet in which trap statuses are notated, and if a trap catches, then biological data such as species, gender, reproductive condition, and weight are taken on each individual. A 3-digit ear tag is then given to each individual for identification purposes, which is illustrated in the upper right image. It is worth notating that the image on the upper left depicts a pregnant female deer mouse, and the image Directly adjacent to it on the right is an image of a male house mouse. This graph represents our mouse densities across all three of our trapping grids beginning in July 2015 when capture-recapture data was first collected, all the way until July 2023, which represents a vast majority of our pre-wildfire data. It is important to notate the differences in y-axis magnitude as each grid supports a different habitat, different population size. It is also important to notate the seasonal fluctuations within the populations of the two mouse species, as well as the fluctuations within each specific species population, as house mouse populations appear to be more volatile than deer mouse populations. This is a GLMM effects plot that was created for our 2021 annual report to the United States Navy. This plot was important as it allowed us to draw a direct correlation between mouse densities, rainfall, and vegetation abundance. Our three historic trapping grids are normally checked 4 times a year on a quarterly basis. This fire was unique in that it occurred just 2 weeks after our regularly scheduled July grid check and allowed us to implement 2 unscheduled grid checks of just the Twin Dams grid occurring 1 month post-fire and 3 months post-fire. The data collected from these unscheduled checks was also added to data collected from the regularly scheduled December check of all 3 grids, allowing us to examine the changes on the mouse densities over a total of 5-month period. This graph represents the last sampling that occurred before the July 25th fire, represented by the vertical dashed line here. Based on the point estimates, we see that both deer and house mouse densities are at about approximately 50 individuals per hectare occurring in July. This graph includes data collected 1 month post-fire, and we can see that house mouse populations have drastically increased, whereas deer mouse populations have just slightly decreased. House mouse densities are at approximately 80 individuals per hectare for August, whereas deer mouse densities are at about approximately 45 individuals per hectare for August. This trend is not at all what we expected to see, as we thought we would see an immediate decline in both populations. This graph includes the data collected from 3 months post-fire, and based on point estimates, we see that deer mouse populations have slightly increased to 50 individuals per hectare, which is the same as pre-wildfire levels, whereas house mouse population has drastically decreased to 25 individuals per hectare, which is approximately half of pre-wildfire levels. This graph includes data from the regularly scheduled December check of the grid at 5 months post-fire, in which we can observe that both populations have begun to decline, with house mouse populations falling to approximately 0 individuals per hectare based on point estimates, and deer mouse populations have dropped to approximately 30 individuals per hectare occurring in December. This trend occurring in the 5th month post-fire is more consistent with our initial predictions of both populations decreasing post-wildfire. This graph shows the mean mass of recaptured individuals within our 3 grids. We were unable to find any direct correlation between the effects of the fire and changes in mean mass of recaptured individuals. However, it is worth notating that Twin Dams shows a significantly higher recapture percentage of deer mice versus house mice. This graph shows mouse densities within all 3 of our trapping grids and allows us to be able to compare what house and deer mouse populations are doing in other parts of the island. House mouse populations in both Warsaw and Wall Rock have both increased. Therefore, it is likely that the decline in house mouse populations observed in the Twin Dams grid is a direct result of the effects of wildfire. Although it is harder to make the same direct correlation of a negative impact of wildfire on deer mouse populations as it is house mouse populations, as the changes in the population are less drastic, as well as there was an observed decline in the deer mouse population of Warsaw. However, the deer mouse population has been traditionally more stable when compared with the house mouse populations. Therefore, to observe a significant decline in both populations within Twin Dams suggests that these changes may be due to the effects of wildfire. The reasons for the differences observed between house mouse and deer mouse densities based on the impacts of wildfire may be due to several factors. Our first hypothesis is the differences in seed caching behavior. It's important to notate that although a significant portion of vegetation was removed from the Twin Dams grid, the area has a high volume of large cracks and rocks, which can be observed in this photo here. Upon inspection of the grid, we found that a large number of seed caches survived the fire beneath rocks and within similar cracks. The hypothesis of differences in seed caching behavior is supported by McDonald 2000, in which they observed that rodent species differed significantly in propensity to cache in their home burrow, labeled as ladder hoard, versus in small depots outside the burrow, labeled as scatter hoard. It was observed that scatter hoarding increased with body mass. It is possible that deer mice having a larger mass had a larger volume of caches they were able to exploit as opposed to house mouse, allowing them to better withstand the immediate impacts of wildfire. The second reason for the differences in mouse densities is labeled as hypothesis 2, which is the differences in ability to adapt to resource shortages. Due to the significant loss of their primary food source, we hypothesize that the mice populations are altering their diets to try and offset the pressures caused by resource shortages due to wildfire. This notion is supported by Anderson 2014 and York 2022, in which they observed that mice populations will alter their diets after a fire to include insects that survived, as well as new grass shoots that begin to sprout immediately after a fire. We observed new grass shoots appearing in the Twin Dams in the third month post-fire. We hypothesize that deer mice are better adapted to exploit these new limited resources as opposed to house mice, possibly causing the differences in population densities between the two species. The third factor based on the effects of wildfire is increased predation. With mice populations being a vital resource for so many species on the island, we hypothesize that due to the loss of vegetation ground cover, mice populations are more vulnerable to predation. This hypothesis is supported by Puglianis 2023, which they stated that it has been observed that interspecific competition increases rodent foraging activity rates, thus resulting in an increase in the predation risk. We hypothesize that the decline in populations observed in the fifth month post-wildfire may be directly attributed to increased predation. This study is still in its early stages, and further observations and data collection will be needed. I just want to give a quick thank you to the United States Navy Pacific Fleet for their funding and support, as well as the project manager, Hunter Cole, as his help was vital to this talk.